Hello everyone. In this video, I am going to explain the complexity analysis of algorithm. In designing of algorithm, complexity analysis of an algorithm is an essential aspect. Mainly, algorithmic complexity is concerned about its performance, like how fast or slow it works. The complexity of an algorithm describes the efficiency of the algorithm in terms of the amount of the memory required to process the data and the processing time. So as I mentioned in my previous video on analysis of algorithm, I mentioned that complexity of an algorithm is analyzed in two perspectives, time and space. Time complexity is a function that describes the amount of time required to run an algorithm in terms of the size of the input. So time can mean the number of memory access performed, the number of comparisons between integers, the number of times some inner loops is executed, or some other natural unit related to the amount of real time the algorithm will take. Then we have space complexity, which is a function that describes the amount of memory an algorithm takes in terms of the size of input to the algorithm. We often speak of extra memory needed, not counting the memory needed to store the input itself. Again, we use natural but fixed length units to measure this. So space complexity is sometimes ignored because the space used is minimal or it's like obvious. However, sometimes it's become an important issue as time. So as I mentioned, the efficiency of an algorithm depends on the amount of time, storage, and other resources required to execute the algorithm. The efficiency is measured with the help of asymptotic notations. An algorithm may not have the same performance for different types of input. With the increase in the input size, the performance will change. The study of change in performance of the algorithm with the change in the order of the input size is defined as asymptotic notation or asymptotic analysis. So asymptotic notations are the mathematical notations used to describe the running time of an algorithm when the input tends towards a particular value or a limiting value. So asymptotic notation is a way of comparing function that ignores constant factors and small input sizes. So there are mainly three asymptotic notations, and those are theta notation, omega notation, and big omega notation. So these notations are important because without expanding the cost of running the algorithm, we cannot estimate the complexity of the algorithm. Now, why is these notations are important? Because they give simple characteristics of an algorithm's efficiency. Then secondly, they allow the comparison of the performance of various algorithms. So in the next video, I am going to show how these theta, omega and big O notations are used to analyze the complexity of an algorithm. Thank you.